Hey guys, welcome to the fourth lesson on fundamentals of C# programming. Today we're going to be talking about how we use arrays in C#. We're going to cover what an array is, how we use them, and when we should use them. Alright, so let's get started. So, what is an array? An array is an object that holds a list of data of all the same data type. It can hold as many items as you want, but it all has to be the same data type. Um, Here's an example, the syntax of what an array looks like. An array consists of first the data type of the array. Because all the items are going to be the same, we need to specify our data type. So let's say we'll have an int array. We'll start out. The next thing is we need to specify and say that it is an array. And in C# we do that by putting in square braces like that. So that's saying we're about to create an array variable. Then we're going to name our array. So I'll say my first array. And then we need to assign this variable a value of an array. But to do that, we need a couple of things. The first thing is we need to allocate memory. We need to set aside memory locations that will hold our array information. Because we're having an integer array, we're going to have a list of integers, a bunch of integers smushed together in one object. But we still need to allocate the memory for each one of those integers, so we need to set aside that memory. So to do that, we use the new keyword. The new keyword sets aside the memory that is necessary. So then we have the new keyword, and then the last part of this declaration, and there are several different types of ways to declare an array, and I'll show you them all, but this is the first way. The last part is now we're going to specify how big our array is going to be. We're going to specify how many locations should be set aside. So we'll say int, and then in the square brackets here, we're going to specify how big. So I'll say I'm going to have an array of 3 integers. I'm setting aside 3 locations of integers. Alright, so now that I set aside the memory for my 3 integers stored in this array, I need to now give those memory locations a value. Because this is similar to right now, how it's set up right now. It's similar to doing this. If I had int x, int y, and int z. This is very similar. This created 3 memory locations, but the memory locations don't have the values. This is the same exact thing. We have 3 variables, just like this, 3 integer variables, 3 integer variables, but no value is assigned to them. So they're empty. So we need to assign them. In this case, we would just go like this and give each one a value, and so on. But with my first array, since it's an array, the name for each element of the array is the same. Every integer in this array is called my first array. That's the name. Whereas here, each variable has its own unique name, x, y, and z. That's the difference between just declaring separate arrays and then putting them all into an array. And there are benefits which you'll see of using an array. A lot of benefits, actually. Anyway, so we need to access each integer in this array separately, and we do that by accessing its index through its index. So let's say if I want to assign the first integer in this array the value 5, I would go my first array, and then in square blocks I would put a 0 equals 5. The 0 just means the first element of the array. Since we're programming, when we count in programming, we always start with 0 as the first. So 0 is the first, and 1 is the second, and 2 is the third, so on. So the 0, we're saying access the first element of this array and assign it the value of 5. I'm going to do that for the other ones. So this is the second one, 6, and then the third one, I'll give it a 7. So now we created our array of 3 memory locations and 3 integers, and then we assigned each integer a value. You can think of my first array sub 0 as an integer. This is the same thing as int x equals 5. This is an integer in its own. It's its own memory location, its own everything. It's just stored into one object called my first array. That's the only thing different. Now, before I go on to more stuff with arrays, I just want to show you the other ways that you can initialize an array and create an array. So this is one way. I could just specify how big it is, and then later on I can go and put and fill in the memory locations myself. Another way we could do this is saying I'll say my second array. I can still specify how big I want it, so I'll say 3. But this time, I can also, in curly braces, I can um, right here, I can specify what each element will be. So in this declaration right here, I still have my 3 memory locations, but now right away I'm saying the first memory location, or the first integer, is going to be 100. The second one is going to be 30, and the third one is going to be 60. It's the same exact thing as doing it like this, but in here I just did it right in the same line of code. I could have specified each of them like that down here, but instead I put it like this. So just know that the first one is the first element, second and third element, like that. So if I were to access the first element of this array, there would be a value 100 stored in there right now. The third way to do it is like this. So the third way is we can omit how big our array is. We don't have to specify a 3. We can omit that 3 and just put it like this, and then the compiler will assume how big the array is based off of how many elements are in its initialization block right here. So since we put in 3 here, this array will have 3 integers. Again, it will allocate 3 memory locations for this. So we can omit that. And the last one, the last way we can do this is omit this all completely. The compiler can assume that it has to do these, it has to use the new keyword and set aside the memory. It can assume all that. So by just specifying my last array equals 13060, it automatically sets aside the 3 integer memory locations and with the new keyword, and it knows that the array has 3 integers in it. So these are all 4 ways that you could do it. Most commonly used are the first and the last. The first because we want to specify how big it is, and then later in the code we'll have to use this based off of a user entered in the values for the array or etc. We don't always know the values of the array at the time that the array is created, so that's why we would use this a lot. And the last one is used the most also because these are all like almost identical, so the least typing is the one that omits all of this. So that's why this is also used a lot. Alright, so now let's get into a little bit of why we use arrays and how loops can help us use arrays and why loops and arrays go hand to hand. So first off, we need to realize what is the benefit of using an array. And there are lots of benefits, one being that we can use for loops to iterate over arrays, which I'll show you. But just to think about it logically, if we had to make a program, let's say that like a teacher program that recorded the grades for all the teacher's students and something like that, and let's say we wanted to store each student's final grade into a integer variable so we can use it, or a double variable, something that doesn't really matter. Normally, if we didn't have arrays, we would have to sit there and declare variables for all our students and continue to go like this and so on forever and put all my grades in. I'll have like 30 variables, and it would be really hard to maintain. It would be really hard to modify my students' grades. And what if, God forbid, another student came into my class and I have to remake the whole program, make more variables, and redesign everything? It's just not practical. That's why arrays come handy in one way like this. And the second way why it comes handy is that we can use loops to iterate over arrays to help us with stuff. So for example, let's say we had an array called scores, and these are just some scores of some students. So we have 5 scores. And let's say this is their test grades from the final exam. And let's say we wanted to add in some extra credit. We wanted to give every student 3 extra points on their exam. So these are our students' grades. One way we could do it without using loops is we would have to sit here and go like this: score 0 plus equals 3, right? And first of all, I could do this because score 0 evaluates to an integer. This is the same exact thing as saying int x equals 5 and then x plus equals 3. X is an integer, and plus equal just takes the value to the left, to the right, and assigns and adds that to the value of the left. So going score sub 0 plus equals 3 is okay because score sub 0 is an integer. Then I would have to continuously do this for all my students and go 1, 2, 3, and 4. Alright, so I would have to type this all out, and now all my students have extra credit. Each student got 3 extra points on their exam. Now, let's say I had 50 students, or 100 students, or 30 students. Doesn't really matter. I would have to sit there and do this for each student. And it could take a long time depending on how many students we have. That's useless, and that's not practical. So instead of doing this, which even though this worked fine, if I were to display all my grades now, everyone would have the extra credit of 3 points. But there's an easier way to do this using loops. Because loops, if you remember from the last lesson, loops have a counter control variable. There's a variable in a loop that's counting, depending on how we set it up, from any range that we set up. Now if you look at the array has a range also. The array starts at 0 and goes to 4 in this case, because we have 5 elements. So there's a range, 0, 1, 2, 3, 4. So instead of explicitly saying each element number, we can use a for loop because it has a counter control variable that's counting through all these numbers already. So for example, if I wanted to do the same thing in this with a for loop, it would look like this. I'll set up my for loop saying int I equals 0. So my for loop counter control variable is I, and it's starting at 0, which is ironically the same index of our first element of our array. Then I want to say my for loop is going to go for as long as I is less than 5 because I have 5 elements in my array, and then every time it's going to increment by 1. This is all from the last lesson. Now that I have my for loop set up, now I can simply, if I want to give all my students extra credit, I can say scores sub I plus equals 3. Instead of saying 0, 1, 2, 3, or 4, if I say score sub I, when the for loop goes off, I eventually becomes all the numbers 0, 1, 2, 3, and 4. So this goes through the whole array index in one line of code and gives everyone extra credit in one line. So for this, just understand that I is actually counting through all of these already. So I can use that as my benefit just by passing that into an array index, and then it will go through each element of the array, adding it 3 because of the for loop. Now, this is also, so let me take away this. Now this is good. I give everyone extra credit, but what happens if this happens? And another student gets entered in and another grade gets entered into my system. Now, wherever I'm using and iterating over my for loop, wherever I'm iterating over the array, I'll have to go back and change the condition in my for loop to a 6 now because I have an extra student. That isn't practical to do all the time. So the integer arrays have a built-in length property. A length property, we haven't gone over classes yet, but a property, you can think of just a variable. A property is a variable, and so we have a variable called length in an array. The length property tells us how long the array is no matter what. It's always changing and always dynamically getting bigger, so we only have to specify the length once, and if the array gets bigger, it still works. So to do that, I just say as long as I is less than score, that's my array, dot length. Now I say score dot length, no matter how long my array is, and whether it changes at runtime or it doesn't matter, which Actually, take that back. It can't change at runtime. I'll talk about that. But depending on when it changes and stuff like that, I don't have to modify my for loop in order to fix that. So now everything is set in stone. My length is so in this case we have 6 elements. My length property will be 6. So I is less than 6 is proper. So this will work. This will give all my students extra credit. Alright, so before I continue on to more array stuff, I just want to, now that we have all our students having extra credit, I want to show you how we can display all our students into the console and display everyone's new grade. Now, I could do it in this for loop, but I want to separate it just so you can see how it would be to display elements of an array. So, once again, I start off with the same thing. The for loop is going to be the same. Because the for loop, this is just the basic for setting up to iterate over my array. But instead of adding 3 to all my students' grades, here I'll just display my students' grades. So I'll be like console.writeLine. I'll say student number. I'll do a placeholder. And then I'll do a colon, and this will be his grade. So my first one is going to be I, which I'm going to change in a second. And my second one is going to be score sub I. Okay, I'll explain this. First, I'm going to first change this I. Normally, if I put this I in, it will say student 0. The first time this displays, it will say student 0 and then his grade, and then student 1. That although that's accurate in programming terms, since the user doesn't want to deal with programming, we want to increment this by 1 always. So now it will always start out with 1 when it's displaying. So it will say student 1, student 2, student 3, and then student 5 at the end. That's what we properly want there. The second one is, this is where we're going to put our grade in. So just like how we incremented each one, we said score sub I plus equal 3. That added everyone's score plus 3. This just displays everyone's score using score sub I, since we're not modifying it. This just displays it. This replaces this placeholder with whatever value is in this integer. Score sub I is an integer. As you can see, even if I highlight it, it says int. Oh, wait, that's for the counter control. It's an integer array, but anyway. So this is an integer. So, yeah, okay. So let's run the program. So as you can see, hold on, there we go. As you can see, all my students originally had their grades up here. They were 176, 88, and so on. After my extra credit kicked in, we see the new final grades. 103, 79, 91, 103, 93, and 73. So all my students got extra credit and so on. Now, let's say I wanted to add a couple more scores, just like this. Just like that. I don't have to modify any of my loops, anything, because I'm using the length property. I rerun the program, and boom, everything is set in. All my students are updated. Everyone got their extra credit, and it displayed everyone without modifying any loop. So this is one example of displaying things to the console. Okay, now we're gonna work with how we can search an array. The way I'm gonna show you is not the only way you can search arrays. There's actually lots of ways. The way I'm gonna show you is how we program a sequential search, meaning that we check everything and go in a straight line, sort of. I'll show you what I mean with sequential search. There are lots of other ways to do it, one being a binary search. I'm not sure if I'm going to go over that in this lesson, but there are other ways, just to note. Okay, so let's get started. So let's say we wanted to make a program that had an array of valid values or valid order numbers. And we were making a program that the user entered in an order number, and we had to check the array to make sure that we had that order number or that item in stock. our array will have all the order numbers, all the item numbers of items that we have in stock at our store. So when they enter in the order number, we'll see if the item is in stock or not based off our array. So to start off, we can make our array of valid values, and we'll say 101, 108, 201, 213, 266, 30. All right, so these are all our valid items that we have in our store, and these are their order numbers. So now we're going to ask the user or the employee to enter a order number. So we want them to enter in an order number. We're going to store that order number into an integer. This is all from the earlier lessons, though, if you don't know what I'm doing right now. Equals int.parse. Alright, so now we have our order number stored into our order number variable. Now we want to add, now we need one more variable. And we need one more variable to tell the user if the item is in stock or not. Although there are several ways to do this, and I really mean there are several ways to do this. There's so many ways you can reprogram this in different ways. I'm just showing you one way, and there are other ways. So in this way, I want to use a Boolean variable. Now, I'll explain why. I'm using this bool variable to tell the user if the item is in stock or not. We're going to start out with saying the item is not in stock by making it false. But once we check for it if it's in stock or not, if we mark it true, then we'll know it's in stock. So now we need to iterate over our array and compare our array with whatever order number was typed in. If the order number was typed in matches any of the numbers in this array, that means that we had that item in stock. So we'll use a standard for loop to iterate over an array. These are always normally the same. Length I plus plus. It's always like that. And then now inside, every time we iterate, we're going to do a check. So because every time it iterates once, the for loop has the value of one element. So when it starts off the first time, the for loop has the value of 101. So we're going to check whatever was typed in against that 101 and so on. So whatever was typed in and stored into order number, so we're going to say if order number is equal to valid values sub I. So the first time around, valid values sub I is going to be 101 because I is 0. Then the second time I goes to 1, so then valid values sub 1 will be 108. Every time it does that, it's checking against order number. If they do match, and we found a match, then we're going to say item in stock equals true, meaning our item is in stock and we have it. Now, I could leave my for loop like this, right? This works, but however, we are wasting time in this code right now. Especially if our program was really, if we had a lot of items in our store, this would take a lot of time doing it this way. So one way to speed this up is breaking out of the loop once we find our items in stock. Because in this example, right when we find our items in stock, let's say the first element is 101, right? And if we entered in a 101 and we were looking for that item, it would find our item in stock the first time around. But because we didn't program it otherwise, it would continue to search the other items of the array until the last item, because that's what the for loop is programmed to do. But we already found our item, so that's a complete waste of time. So one way to fix this is we can add in a break statement, and our break statement will say right when once we find our item in stock, break and break out of the loop, and don't continue to do the rest of the loop. So that's one way to speed it up. Although this is not practical, because if we were working at a store and we had a program that was managing what items are in stock or not, we wouldn't use the sequential search like this because it would take too long. This would be more practical for a binary search method, but a binary search requires your items array to be in numerical order, ascending order. Although our array is, so we could use the binary search. I'm not going to go over the binary search right now, but just note that in this case, the binary search would most likely work. Because yeah. Anyway, okay, so yeah, so now we found our item in stock and we're breaking it out. So once we break out of the loop down here, now we're going to do our check to see if our item is in stock actually. We also could have displayed if our item was in stock here, but this is just easier over here. So we could put in the else part and save the item is not in stock. So down here we're going to say if item in stock equals true, then display to the users or to the employee that the item is in stock. Else, we're going to display we're going to say sorry, the item is not in stock. So there we go. This is our program. We have our array of all our items. They enter in. We do a check to see if our item is in stock. If it is, we set our variable to true. We break out of the loop, and then we do the check down here. If the item is in stock, the item is in stock, and sorry, it's not. So let's run the program. So I'm going to enter in an item that is in stock, 266. And we get a message, the item is in stock. Okay, good. Let's enter in one that's not in stock, 500. Sorry, the item is not in stock. So this is a simple program that actually has some practical use to it. If we were searching an inventory or a database or something, checking if an item is in stock in our back closet or something in a store. So yeah, this does have some practical use. This is the beginning of real programming, and so on. All right. Alright, so now I want to modify this program a tiny bit more. I want to modify it and I want to show the user that if the item is stock, I want to display the price of the item to the customer. So if an employee is saying if a customer is asking the employee, hey, is this item in stock? The employee can go to its computer, look it up, and say yes, and they can tell the customer how much it costs also. So in this case, I'm gonna have to use a parallel array. I'm gonna use a parallel array is a concept of just saying that the two arrays have the same amount of items in it, so we can use the same index to access the items. So in this case, I'm just gonna copy this. I created a parallel array called prices, double prices. And they has the same amount of items. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So they both are the same length. So that means that the first item represents the first price. The last item represents the last price. And in the middle, each item represents its price respectively, which makes it really handy for us. So the first thing we need to do to modify this program to get the price is we need to make a variable down here that's going to hold our price of our item. So now this is gonna hold our price. So when we're in the for loop, we can set the price here so that we can display it down here. So now when we're in the for loop, and this is right here, that's the code for if we found an item that matches the item entered in. So if that is the case, here we're going to set the price of the item. So what we're going to do is, so we can set it here. We're going to say our price is equal to our prices sub I. Now, this might be a little confusing. Valid value, so our for loop is going in counting from 0 to 9 in this case. If we're inside this if block, we can assume that the I value is the same. Well, hold on, scratch that. If we're inside this if block, valid value sub I represents one of the numbers. So for instance, let's say it represents the 213 here, which is index 0, 1, 2, 3, 4. No, 3. It's index 3. So I, in this case, is index 3. So because I is 3 right here, I is also 3 right here. So if I'm saying price is 3, which is this, I mean, if I'm saying valid value is 3, which is that, if I just swap the I with prices and I say price is 3 is this. So that's how they are connected with the same I. Since they had the same exact length, the I variable, or the counter, is linked between both of them. So that's how we can use the I. So valid values I, let's say it represents the first one. Prices I represents the first in prices. So now our price is set based off of the price there. So now if we say the item is in stock, and we can say comma, and the price is placeholder, comma, price to string C for currency. I showed you this in the last lesson, so if you don't know what this means, you gotta look that up. But pretty much I'm just saying convert the price, which is a double, to a string and represent it as a currency format. And then put that into the placeholder. So now let's rerun the program. So there's our code. Let's rerun the program. And let's say we want item 266. It says the item in stock and the price is $5.79, which you can see is true. If you look right here, 266 matches up with 579. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There's the price. There's the item. So now this is even a little bit more practical program where we not only look up and check if the item is in stock, we can then return also the price of the item. Okay, now I want to talk about just two built-in functions, or two built-in actions, because I haven't gone over functions yet, of the array class. I'll be talking about classes and stuff like that, but in later lessons, but console is a class, and there are lots of classes. We're actually in a class called class program, but all that will be explained at later lessons. But there's two built-in functions that I think might be useful to us. Someone delete this. So first, I'm just going to make an array of strings. String array called names. Set it equal to, okay, Olive, Patty, Richard, Ned, and Mindy. Alright, there's our string array. Now, one function is called the sort function. So I can go array dot sort, pass the names, and now this will sort. So array, the syntax is array dot sort, and then you pass the names, and this will sort my array. Now, before I display and show you this, there are many ways to sort things in programming. They're all based off of algorithms. I'm not positive of what algorithm that this built-in sort function is using, but there are plenty of algorithms. One being that it's probably using what is called a bubble sort, and I'm not going to explain how a bubble sort works here. It's pretty advanced, but maybe in later lessons I'll explain how bubble sorting works and things like that. But there are many types of sorting techniques. So let's display this to the console. So we're displaying name sub I to the console, and we sorted it. So now if you run the program, you'll see that it's in alphabetical order, M, N, O, P, Q, R. Yeah, so it's all in order. So that's one sort. You can sort any type almost. You can sort any intrinsic type for sure. So like integers, doubles, anything like that, strings. You can sort anything in any order you want. There's also one more function I want to show you. It's called the reverse function. Run the program. You can obviously know what it does. It reverses the order. So this was the original order, Olive to Mindy. Now it's Mindy to Olive. So I just reversed the order of the array. Now, these, like I said, these built-in functions they were just defined and already coded for us, but we can program all these actions and build our own functions. Eventually, once I teach what functions are, that can do this code also. They're just simple algorithms, and once you understand the algorithm, you can make your own versions of them and reprogram it however you want it to, whatever you want it to do. Um, and maybe in later lessons I will, if people want to see how things behind the hood work and how Microsoft programmed these, and maybe I will do that in later lessons. But yeah, so these are two built-in array.sort, array.reverse. That might be handy when you're using arrays and working with stuff that you want to make it look nicer or anything. Oh, and one more thing. With the array.sort, I didn't go over binary search, but if you are into programming and want to learn what binary searches are, you can go ahead and look it up. But a binary search requires that your array or whatever you're using it on is in ascending order. So or you can use array.sort to sort your array, and then use the binary search to do it. All right, the last thing I want to do in this lesson is make a little program, a little teacher program. The program is going to ask the user to enter in how many students they have in their class. Once they enter in the students, we're going to build an array based off of that. Um, we're going to build an array based off of how many students they entered in. Now, one thing to note about arrays is that arrays arrays size can't change during the execution of the program. Once you set how big the array is, it can't get bigger or get smaller. So if you say an array has 3 elements or 3 memory locations, you can't say later in the program, if you don't reassign it, that is, you can't make that array get bigger or smaller. Um, there are, however, different types of collections or collection types that can get bigger and smaller. We will go over them in later lessons, but for one is a list. A list can get bigger and smaller however you want, and it uses the same kind of indexing features of an array, so that it functions the same way as an array, but it can get bigger and smaller. However, even a list, deep down behind the code of a list, there are arrays in the core of even a list that can get bigger and smaller. So arrays are always important; they're always there. Um, but just note that arrays can't get bigger and smaller during the runtime of a program. But however, in this program that we're going to make, we're going to specify the size in runtime, and then it will build that array based then, and then it won't change. So this will still work. So it's going to build an array based off of how many students we tell that our class has. Then we're going to ask the user to enter in the grade for each student. And then we'll fill the array at runtime then also. Then the last thing we're going to do is, oh no, 2 more things. We're going to then display all the students' grades, which we already did once, while we're calculating the average for the class. So that's what we're going to do, build a program that can calculate the average of a class. So let's get started. The first thing we're going to do is ask the user, or teacher in this case, to enter the number of students. Then we're going to store that into a number of students variable. Now we're going to create an array based off of how many students we have. So we'll say double, because the students' grades can have decimal points, so we're going to use a double. I'm going to say my students equals new double array, and the double array is going to be so normally I would put in a number here to say how big my array is, but my integer number of array works also because it's an integer, and then I can just pass that in, and whatever students they entered in, how many students, that's how big I'll make my array. Now that I have that, now I need to fill each slot with the grade of the student. So I want to make a for loop and say int I equals 0, I is less than my students.length, I plus plus. Every time I'm going to ask the teacher to enter in the grade of that student. So enter grade for student number placeholder. I want to do a backslash and I plus 1. Okay, so first thing to note, console.writeLine, this is basic statement. The backslash n just means go to a new line. I think I went over this yeah, I did in a previous lesson. Backslash n is an escape character that just breaks to a new line. And then we're filling the placeholder with I plus 1 because we want the user to see, we don't want the user to see enter grade for student 0. We want the user to see enter grade for student 1 as the first student. So that's why we do that. And now we're going to fill in. So we'll do my student sub I because we're in the for loop, and that will represent each student, and we'll say that's going to be equal to double.parse console.readLine. It's double.parse because where is it? Because my student array is a double array, so that's why it's double.parse. And like I said, we can use, since my student sub I is a double, you can treat this as a double. So we can use double.parse because double.parse returns double, and then that can be stored into this, no problem. The same thing as doing it here. My int number of students equals int.parse. Number of students is an integer, so that's why we could do it. Yeah, so this will store whatever was typed in for this, whatever student we're on, into that array slot, and then since it's in a loop, it will keep on doing that for each student. So this will store a grade for each student in this line of code, in these lines of code. Now that we have that, let's redisplay the students all together, and we'll calculate the average at the same time. So if you want to do the average, we're gonna make a double that's gonna start holding the values of the average. Because remember when I said in the last lesson, I said that there's times that you want to keep a running total, and it always comes up. And here's an example that we need to keep a running total. So our average variable is going to keep the running total, because to calculate the average, if you remember from elementary school math, you need to add all your things, all your grades together, and then divide by how big the how many students you have. So that's why we need a running total. So this time we're going to need another for loop that will go over the array, printing out all my students' grades, and at the same time making my running total of my average for my average. So I'll make the array again. My students sub I length I plus plus. Come on. Alright. Now, first we'll calculate the average. We'll make our running total. So we'll say average plus equal my students sub I. So this is saying every time it runs, add to my average whatever the value of my student sub I is. And my student sub I is the value of whatever was entered in that slot. Because the for loop is going over each slot, so this will fill in, this will keep the running total of average. And then I also want to, just because I want to display all my students, I'm going to use the backslash student number placeholder, and then their grade will go here. I want another backslash and then the first placeholder is going to be I plus 1, because that's the student number, and the second one is just going to be my students sub I. So my students sub I, we're going to put in their grade here. You can see the same thing. I'm adding the grade to the average here, and here I'm just displaying that same exact grade next to the student number so we can display it. So there we go. We displayed all our students and we added it into an average. And now the last thing we want to do is just display the average of my class. So there's our placeholder, and in our placeholder slot, I'm just going to do, so we have our average is all our students added together, and the last thing we need to divide it by how many students we have. So we'll do average divided by, there's a couple ways we could do that. Since we have a variable called number of students, we could use that, or we can use my students.length, because that's how many students that we have also that's stored into the array. So both of those will work. So this is our entire program. This is a pretty robust program. It's pretty well made, and it's pretty practical also, to be honest. So enter the number of students. I'll say we have 5 students. So now let's enter the grade for student number 1. I'll say he got a 50. The next guy got a 70. Yeah, 70, 87, 95, 96, and a 65. Right when I hit enter, it will re-display all my students. So you can see 50, 70, 87, 96, 65. That's all right here for all my students. So you can see that this is each memory location, each slot, and it's displayed like that. And then the last thing, the class average is a 79.6. So we calculated the average and everything in this program. So this is a pretty decently made program. Like I said, it's pretty. If you can understand all the concepts in this program, you're coming along really well. If you start these lessons from not knowing program at all or little knowledge of programming. So yeah, if you can understand this, that's really, really, really good. All right, so that's the end of this lesson. And if you guys have any questions or don't understand something in any of the lessons, you can always post comments and I'll get back to you explaining it. You can also request things that you want to learn, or if you're personally studying things on your own and you don't understand something, you can go ahead and shoot me uh, either an email or write a comment, and I'll be sure to get back to you. I can help you with whatever you're doing. So if you have any questions with programming in C Sharp, by all means you can ask. I'll eventually be making lessons on C++ and Java also, but right now we're just working on C Sharp. So yeah, that's the end of the lessons. I hope everyone enjoyed it, and thank you for watching.